Hey everyone, welcome back to another CIE A Level Maths past paper video. Today we're going to talk about the 3 exam from the May-June 2020-25 and variant 3-2. So let's jump into the paper. Solve the equation e raised to power x plus 2 e raised to power minus x divided by e raised to power x minus 3. Give your answer correct to 3 decimal places. Okay, so the first thing we can do is multiply this thing on this side. This becomes e raised to power x plus 2 e raised to power minus x 4 e raised to power x minus 12. Okay, so we take this e on this side, which would make it 2 e raised to power minus x. 4 minus 1, this is 3 e raised to power x minus 12. Right, okay. So what we can do, what we need is to get rid of this negative 1. So we can multiply both sides by e raised to power x. So what this will do is it will get rid of this minus. So e raised to power minus x times by e raised to power x would just be 1. So 2 is equal to 3 e raised to power 2x minus 12 e raised to power x. So as you can see, this has become sort of like a quadratic equation. Minus 2 equal to 0. So this is a quadratic equation in e raised to power x. So let's see if we can find factors for this. So minus 2, 3x squared minus 12x. So 3, 2. Right, okay. There is no way we can actually get 12. So I think we will need the quadratic formula then, okay? Right, so e raised to power x would be minus b, 12, plus minus b squared, minus 4ac, 4 times by 3 times by minus 2, so this would become this, divided by 2 times by 3, 6. Alright, so let's figure this out. So 12 plus 144 plus 24, sorry, 4 times by 3 times by 2, that is 24, and this is 6. Right, so one answer is 2 plus root 42 over 3, and the other answer would be 2 minus root 42 over 3. Now the e of x function, it goes like this, so we can't have a negative answer, so all we need is to just take the ln of this option. So x is going to be ln of 2 plus root 42 over 3. Sorry, wait. Sorry, I accidentally wrote it this way. Just this. Okay. Plus answer. Yeah, we got this. So how many decimal places? 3 decimal places. So 1.426. Right, and that's the first question. Let's move on to the next one. Question number 2. Expand 6 minus x, 1 minus 2x raised to power 3 minus 2, 3 over 2, in ascending powers of x, including and up to include. Expand 6 minus x, 1 minus 2x raised to power 3 minus 2 in ascending powers of x, up to and including the term x squared, simplifying the coefficients. Okay, so first off, what we will need is we'll need to expand this one. So this is already in 1 minus form, so this would be like straightforward. So 1 minus 2x minus 3 over 2. So we remember the formula: 1 plus minus 3 over 2 minus 2x plus minus 3 over 2 minus 3 over 2 minus 1, this is minus 5 over 2, divided by 2 factorial times by minus 2x whole squared. 1, this becomes 3x, and right. So minus 1.5 times by minus 2.5 divided by 2 times by 4, so this is 7.5, 15 over 2 x squared. Okay, now we need to multiply 6 minus x with it, so 6 minus x, 1 minus 2x raised to power minus 3 over 2. This would be 6 times by this. Since we need up till the x squared term, so we need to multiply up till the x squared term. Minus x, 1 plus 3x plus 15 over 2 x squared. Okay, so this is 6 plus 18x plus 3 times by 6 times 6 divided by 2, 3 times by 15 is 45 x squared minus x minus 3x squared minus 15 over 2 x squared. So this would become 18 minus x is 17x. 45 minus 3 is 42. And 42 minus 7.5 is 69 over 2 x squared. Sorry, wait, I think I made a mistake. This x, when multiplied with x squared term, this would get x cubed. So, sorry, no. So it's just 45 minus 3x squared. This is 42x cubed. Right, okay. Okay. State the values of x for which the expansion is valid. So remember that 2x has to be less than 1. So 2x has to be less than 1, which means that x mod has to be less than 1 over 2. Okay. Alright, so that's for this question. Let's move on to the next one. On an Argand diagram, shade the region whose points represent complex numbers z which satisfy both the inequalities z minus 3i less than or equal to 2. So this is a circle of radius 2, and the center would be 0, 3i, right? And 1 over 4 pi less than argument z minus, so basically this point is 1 plus 2i, so this is the half line basically starting from this, and the angle is between pi by 4 to 3 pi by 4. Okay, alright, so let's draw that. Right, okay. Right. So 0 minus, this one 0 comma 3i would be, let's say, I 1 3 1 2 3 1 2 3 1 2 3. So somewhat So 0 minus 3i, 0 comma 3i, is this one, and this is the radius, and the circle radius is 2, so we need it up till over here, right? Okay. This is the circle, right? And this point is 1 comma 2i, so this is 1, and 2i is this one. No, this one, sorry. Okay, and we need from pi by 4 is basically 45 degrees. So remember, if we start our pi by 4 line from this, it's going to be y equals to x plus minus something, right? So the gradient of this line is basically, gradient of this line is 1. So basically this is the equation of y is equal to x plus something. And we also know which line, which point is passing through. So we can find out the y-intercept just to get a quick idea of what's going on. So when y is equal to 2, x is equal to 1 for c, so c is 1 also. So basically it's passing from over here. Okay, so I'll just draw the line passing through this, but we don't need to write. Okay, so I'll just erase this. Right, okay. The line is actually starting from over here. Similarly, we need 3 pi by 4, which is 120. So if you just simply forget that, just remember it's just 3/4 of 180 degrees. So 3 times by 180 divided by 4. Oh, sorry, 135. My bad, 135. So we need 45 degrees in the other direction simply, right? So simply, basically you have minus x passing from the same point, right? So let's see where it's actually going to pass. So y is equal to 2 and x is equal to minus 1 for c. So c is actually going to be 3. Right, so it's actually going to pass from the center of the circle, right? Okay, as predicted, right? So the shade, the region that corresponds to this, these two combined would be this particular region, right? And right over here also, right? Okay, done. So now what we need is to clean this up a little bit. So this is your imaginary axis, this is our real axis, right? So this is 3, this is 1 comma 2i, or sorry, just 1 comma 2 also would be suffice, right? Right, okay. Question number 4. Solve the equation 3 cot x minus 4 cot 2x equals to 3 for 0 to x to 180 degrees. Okay, so first off what we need is to convert it into tan. So this is 3 over tan x minus 4 over tan 2x equals to 3. So remember the double angle identity for tan 2x. It's 2 tan of x 1 minus tan squared x. So the reciprocal of tan 2x would be simply this thing, right? So 3 over tan x minus 4 1 minus tan squared x over 2 tan of x equals to 3. Now just to make the denominators the same, you can multiply 2 and 2 with this one. So we multiply 2 tan x on the other side, so 6 minus 4 times by 1 minus tan squared x equals to 3 times by 2 tan of x. This is 6 minus 4 plus 4 tan squared x equals to 6 tan of x. You have 4 tan squared x minus 6 tan of x plus 2 equal to 0, and when you divide this entire equation by 2, you get 2 tan squared x minus 3 tan of x plus 1 equals to 0. Right, okay. Now let's see if we can figure out factors for this quadratic equation. So you have 1, you have 2x squared, let's say 3x negative. So 2, 2, 1, and 1. Sorry, no. What am I doing over here? X. So 2x minus x, only way this happens is they are both negative, right? So 2 tan x minus 1 and tan of x minus 1, 0. So this means that either tan of x is 1 over 2 or tan of x is 1. So tan of x 1 only happens with 45 degrees, right? Because from 0 to 180 degrees, it goes like this. This is your 90 degrees, and this would go like this, right? So both values are positive, so that means both values are supposed to be less than 90 degrees. So tan inverse of 1 over 2. So x is 26.6 degrees. So x is either 26.6 degrees or 45 degrees. Right. Let's move on to the next question. Question number 5. The square roots of minus 1 minus 4 square root 5i can be expressed in the Cartesian form this, where x and y are real and exact. By first forming a quartic equation in x or y, find the square roots of this in exact Cartesian form. So since we're talking about the square roots of this minus 1 minus 4 root 5 I, right, being equal to x plus I y, this means that the square would be this, right? So what we will further do is minus 1 minus 4 root 5 I is identical to the square of this thing. So this is x squared plus xyi plus xyi plus I squared y. So basically this would turn into negative y squared. So this is basically x squared minus y squared plus 2xyi. This is the real part. Minus 1 minus 4 root 5i. So this means that minus 1 is identical to x squared minus y squared, and minus 4 root 5 is identical to 2xy. Right. This means that xy is minus 2 root 5. Okay, so basically this could mean that y could be written as minus 2 root 5 over x. Okay, now we plug this into this equation. So this would become minus 1 x squared. Y squared would become 4 times by 5 over x squared. So multiply the x squared, all three terms. This would become minus x squared, x raised to power 4 minus 20. This has become x raised to power 4 plus x squared minus 20 equal to 0. Now notice this is the quartic equation that they are talking about. So basically the solutions will come out in the form of x squared. So basically let's say this is u squared, this is u minus 20. So this is your u squared minus 20 u, so minus 20 over here and plus u. So 5 and 4 will give us the answer. But which one of them is negative? So since we need a positive, so 5u minus 4u will be the right answer. So you have x squared plus 5 or x squared minus 4 being equal to 0. Since x and y themselves are real, this equation will not give us the right answer. Only this will get us the correct answer. So x is plus minus 2. So if x is plus minus 2, we can get the corresponding y's. Right? So when x is equal to 2, y would be minus 2 root 5 over 2, which would mean that this is minus root 5. When x is equal to minus 2, y would be minus 2 root 5 over negative 2. So this would be just root 5. So we have we have square roots. Actually, like there are roots conjugates of each other in a way. So you have 2 minus I root 5 and minus 2 plus I root 5. Both of these are the square roots of this expression, minus 1 minus 4 root 5. Right, okay, let's move on to the next question. Okay, so question number 6. By sketching a suitable pair of graphs, show that the equation x minus 2 sine half of x has only one root in the interval 0 to 5. Okay, so let's just gently sketch them one by one separately, and then I'll show you how to deal with it together. So x minus 2 will be sort of like a V-shaped graph where this is 2 and this is also 2 because it's going x minus 2 and 2 minus x. This is your 2 minus x and this is your x minus 2. Basically sort of like a piecewise function. You can watch our videos in the revision playlist how to sketch this. And this is 2 over here, so it will be 2 back again at 4. Right? 2 sine half of x will do is it will make it jump between 2 and minus 2, but half of x actually doubles the period. So period rather than 2 pi is going to be 4 pi. So this means half will be at 2 pi, quarter at pi. This would mean that this is at, let's say, 3.141. So this would be somewhere this this way over here. So this is what we just have to draw, right? Rough. Okay. So slightly better than what I meant. So this is our y-axis. This is our x-axis. 1, 2, 3. 1, 2, 3. 1, 2, 3, 4, 5. Okay. So this is 2. This is 2. This is 4. So if I just draw a very thin line over here to show the range of the sine function, because 2 is the amplitude, so it's jumping in between that. So the mod function, 2 and at 4, right? And the other one, sine, so this is like 3.141 pi, so roughly at, let's say, over here. So this would go right at the maximum. That's it. This is your pi. Okay, so as you can see, there is only one point of intersection between these curves, so that's all what we need to show. So this is your y-axis, this is your x-axis. You can trim it down a little bit. We don't need this thing. That's it. This is your x-axis. Let's label the graphs. This is your y is equal to mod x minus 2, and this is your 2 sine half of x. So we need to show, we need to write over here only one point of intersection implies only one solution in the range 0 to pi. Right, okay. Show by calculation that this root lies between 1 and 1.5. Okay. So for example, let's make f of x to be mod of x minus 2 minus 2 sine half of x. We plug in 1. So 1 minus 2 is minus 1, but mod of minus 1 is just 1. Minus 2 sine half of 1. And for 1.5, we would need 1.5 minus 2 is minus 0.5, but mod would turn it into 0.5 minus 2 sine half. We can do 0.5 times by 1.5. So this is 1 minus 2 sine 0.5. This is 0.04149. And this is half times by 1.5. And this is 0.5. Right, okay. So 0.086327. So sign changes between the values. Therefore, root lies between this. Root lies between this range. Okay. Use the iterative formula xn plus 1 equals to 2 minus 2 sine half of x with initial value of 1.03 to calculate the root correct to 2 decimal places. Okay. So first off, we need x1 to be 1.03. So x of 2 would be, so first off, 1.03 we will save in the calculator. Okay. So, wait. Right, okay. So, 2 minus 2 sine 0.5 times by answer. So second answer we get 4 decimal places, 1.0149. This would be 1.0281. 1.0166, 1.0266, 1.0179, okay, so I'll continue from over here, right? Okay, so 1.01788 it was something, so this would be 1.02549, so basically 5, x raised to the power 8. Now we can turn this value into answer back again. 0, 1, 8, 8. Okay, so see the pattern over here. We have actually gone far beyond what we actually needed to do. Since we needed corrected 2 decimal places, to corrected 2 decimal places is 1.02. Okay, so it's hovering in between that. We didn't actually need to go far beyond. Actually, we just needed up till this much, right? We don't need this much. So therefore, x is equal to 1.02. Okay, right. Okay, let's see the next question. Okay, so question number 7. Express 7 sine theta plus 24 cos theta in the form r cos theta minus alpha. Okay, so first we expand this, so r cos theta minus alpha. Let's expand this. So this would be r cos theta cos alpha plus r sine theta sine alpha. So this is identical to this thing. This means that sine theta component is r sine alpha is equal to 7 and r cos alpha is 24. So this would mean that r is 7 squared plus 24 squared whole under root, and alpha would be tan inverse of 7 over 24, the sine component on the top, right? So let's do one by one. So 7 squared plus 24 squared, this is 25, and tan inverse of 7 divided by 24 is 0.2838. Okay, right. So therefore this could be represented as 25 cos theta minus 0.2838 radians. Okay. Now hence solve the equation 7 sine 1 over 3x plus 24 cos 1 over 3x equals to 24.5. Okay. So what we will do over here, we know that we have 25 cos of 1/3 of x minus 0.2838 24.5. So basically we just have 1/3 of x minus 0.2838 equals to cos inverse of 24.5 over 25. Okay, now before we actually find the ranges, we need to recall a few things. Since the value of cosine is positive, so this only happens in the first and the fourth quadrant. But what range do we need to look for answers for this particular value, for the inverse cosine? How far do we need to go? So if you have 0 to x to pi, 1/3 would be pi minus 1, pi by 3. So for minus 0.2838, this would be minus 0.2838, 1/3 of x minus 0.2838 less than pi by 3 minus 0.2838. So notice that the same value of the cosine would be in the negative form also. Okay, so negative of the same value. So if we do the cos inverse of 24.5 divided by 25, you will have 0.033, you will have minus 0.2003 also, which is in the range, right? So therefore x would be 0.20033, or you can keep it in the form of cos inverse of 24.5 over 25 easily, just as easily like that. So okay, we can keep it a little bit accurate. 24.5 over 25, 0.2838 was tan inverse 7 over 24 times by 3, right? And the other answer is minus cos of 24.5 over 25 plus tan inverse of 7 over 24 times by 3. Okay, so we need two values. So this way it will be easier to edit out in the calculator. So cos inverse of 24.5 divided by 25 3 plus tan inverse of 7 divided by 24 brackets. One answer is 1.452. The other answer would be just simply swapping out the negative sign over here. This would be 0.251. Right, so basically that's about it. So 0.251 and 1.45. Three significant figures for both of them. Right, okay, so let's move on. Okay. So question number 8. The variables x and theta satisfy the differential equation. This, okay. When x is equal to 0, theta is equal to pi by 12. Solve the differential equation and obtain an expression for x in terms of theta. Okay. So first we need to separate the variables, right? So sine 2 theta over cos 2 theta. Actually, no. Wait. Dx terms on this side, so 4x plus 3 dx, and this would be cos 2 theta over sine 2 theta d theta. Okay, so let's make few final adjustments. So this is the ln form, so we would multiply and divide by 4 to make the derivative of 4x plus 3 in the numerator, and on the other side you have got of 2 theta d theta. Sorry, I forgot. We will handle it the same way as we do on the left hand side. So basically the derivative of the denominator is on the numerator, so we just have to multiply 2 divided by 1 over 2. Right, now we just have ln 4x plus 3 equals to half ln of sine 2 theta plus c. Now we have the condition that when x is equal to 0, theta is equal to pi by 12. So x is equal to 0, theta is pi by 12. So half ln 3 is equal to half ln sine 2 times by pi by 12 is pi by 6. Pi by 6 is 30 degrees. Sine of 30 degrees is 1 over 2. Okay, plus c. So we need c in the exact form. Right, so this is ln 1 by 4 ln 3. See, this would expand into half of ln 1 minus half of ln 2. Half of ln 1 is 0, so when it goes on the other side, this becomes half of ln 2 c. Right, so c can be written as 4 ln 3, so multiply this by 2, so 2 ln 2. This can be written as 3 times by 4. Right, okay. Now we need the differential equation for x in terms of theta. So therefore we have 1 over 4 ln 4x plus 3 half ln sine of 2 theta plus 1 over 4 ln of 12. Right? Okay, so we multiply both sides by 4 first. We get ln 4x plus 3 is equal to 2 ln sine 2 theta plus ln 12. This becomes ln of 12 sine squared sine 2 theta. Sorry, sine squared 2 theta, and this is ln 4x plus 3. Now we reverse the ln into the exponential form. So we get 4x plus 3 equals to 12 sine squared 2 theta. So we need just x, so this would be 12 sine squared 2 theta minus 3 divided by 4. Right, okay, and that's about it for this question. Let's move on to the next one. Question number 9. With respect to the origin O, the points A, B, C have position vectors given by these. Find a vector equation for the line through A and B. Okay, so through A and B, we first need to find out the vector A and B, because that will be used as direction vector. So OB minus OA would be written as minus 2, 1, 3, minus 1, minus 4, 2. So minus 2 minus 1, minus 3, 1 minus minus 4, which is 1 plus 4, 5, and 3 minus 2 is 1. Right. Yes, okay. This is the direction vector now. So vector equation for the line would be OA plus lambda AB. So this would become 1 minus 4, 2 plus lambda times by minus 3, 5, 1. This is our vector equation for the line through A and B. Right, okay. Using a scalar product, find the exact value of cos BAC. So cosine of BAC would mean that we need, let's say this is BAC. So we need the angle between AB and AC, right? Okay. So AB we already have, but we need to find out AC. So AC would be, OC minus OA. Okay. OC is 235 and OA was 1 minus 4, 2. So this is 2 minus 1, 1, 3 plus 4, 7, and 5 minus 2, 3. Okay. So AB dot AC. Actually, first we can find out the magnitudes. So magnitude of AB would be 3 squared plus 5 squared plus 1 squared square root, and AC would be 1, 7, 3 squared. So 9, so square root of, 9 plus 25 plus 1, this is root 35, and this is 1 plus 49 plus 9, this is 59. Okay, now we can take AB dot AC is equal to root, magnitude of AB, magnitude of AC, cosine of BAC. Okay, so AB was once again minus 351 dot 173, and square root of 35 times by 59 cos of BAC. Now the dot product is going to be minus 3, 35 plus 3 divided by this equals to cos of BAC. Therefore, BAC would be cos inverse of that. So we need it in find the exact value of cosine of that. Right, okay, so we just need the exact value of cosine of that, right? We don't need the angle. Okay, my bad. So you have 35 divided by square root of 35 times by 59. So which is going to be, see, 35 divided by square root of 35 is just going to be square root of 35 over 59. Sorry. Right, okay. Find the exact area of a triangle ABC. Okay, so triangle ABC so we have AB, we have AC, we have this angle in a way, indirectly. So we just need to find the half AB sine theta basically. Right, okay. So we need the value of sine BAC as a matter of fact, right? So let's say you have a triangle, this is your theta. So and cosine of that theta is root 35 over 59. Okay, so what would be this value? So 59 minus 35 is 24, so square root of 24. Right, so this would be square root of 24 over 59. So area would be half times by magnitude of AB, magnitude of AC times by sine of BAC. So half times by square root of 35, square root of 59 times by square root of 24 over 59. Okay, so 59 get cancelled. You have 0.5 times by square root of 35 times by 24, so 210. That is our exact area. Find the quotient and remainder when x squared is divided by 1 plus 4x squared. Okay, so basically you have x squared and you're dividing by 1 plus 4x squared. So it's not necessary that we have to multiply with an integer. We can multiply with a fractional number also. So for example, if you multiply with 1 over 4, you get x squared. See, 1 over 4 times by 4x squared is just x squared, and then plus 1 over 4. So now when we subtract minus, you get minus 1 over 4. This is your remainder. So quotient is 1 over 4 and remainder is minus 1 over 4. Okay. Find the exact value of x tan inverse of 2x. So the derivative of tan inverse is this. You have to keep this in mind. We will use the chain rule to handle tan inverse of minus x. So let's see that. Sorry, tan inverse of x. Sorry, my bad. So basically we will use the integration by parts over here. So remember the isolate or the Liete rule. So the inverse functions will be preferred for u, right? So u, let's say this is tan inverse of 2x. So u prime would be 2 over 1 plus 2x whole squared, so 4x whole squared. Chain rule, right? So v is your x, and your integral v dx is, what was it? X squared over 2. So we do the integration by parts now. So integral is going to be, x tan inverse of 2x dx is going to be u integral of v dx. So 1 over 2 x squared tan inverse of 2x minus u prime 2 over 1 plus 4 x squared times by x squared over 2 dx. Right, so this is where the first part actually comes. So x squared divided by 1 plus 4x squared is actually this thing. So 1 over 4, let's write over here. So 1 over 2 x squared tan inverse of 2x minus integral of, quotient was 1 over 4 plus remainder was minus 1 over 4 1 plus 4 x squared. Right, and this is your dx. Okay, so we'll continue this over here. So half of x squared tan inverse of 2x minus 1 over 4x. Now, see, remember how we actually got it, right? We need we actually got this as the derivative, right? So the integral would be going back. So if you multiply 2 over here and multiply 2 over here, you will have 1 over 8 minus minus plus 1 over 8 tan inverse of 2x, right? And that's about it. From 0 to 0.5. Right, okay. So now what we do is we just simply plug in the limits. As you can see, these terms have the same common tan inverse 2x factor, but it's your choice whether to combine them into one or not. So first we plug in 0.5. So 1 over 2 times by 0.5 squared would just be 1 over 8 tan inverse of 2 times by 0.5, that is just 1, minus 1 over 4 times by 1 over 2, 1 over 8, plus 1 over 8 tan inverse of, again, 1, minus half of 0. Actually, this entire thing would become 0. So 0 minus 0 plus half, 1 over 8 tan inverse of 0. Tan inverse of 0 would also be 0, by the way, simply. So you have tan inverse of 1 is pi by 4. So pi by 4 times by 8, 32. minus 1 over 8 and plus pi by 32 again. So we are left with pi over, see, 1 over 32, 1 over 32 becomes 1 over 16 minus 1 over 8. So did we need the exact answer? Yeah, exact answer. Right, okay, so let's move on to the next question. Question number 11. The diagram shows the graph of 5 sine 2x cos squared x for 0 to pi by 2 and its maximum point M. Find the exact coordinate of M. Okay, so first we need to differentiate. So dy by dx is equal to 5. No. First we need to do this. So if u is 5 sine 2x, u prime would be 10 cos 2x. Then v is cos squared x. V prime would be the derivative of, first we will do 2 cos x, and then the derivative of cos x, which is minus sine x. Okay, so uv prime would be 5 times by 2, 10 times by sine 2x minus cos x sine x sine x and plus 10 cos 2x cos squared x. Okay, wait, hold on. This is sine of x. Okay, so basically we need to figure out which way we want to go. So for example, this way you have 10 sine 2x cos of x sine of x equals to 10 cos of 2x cos of squared x. So as you can see, 10 and 10 will get cancelled, right? Okay, we can't just simply cancel out the trigonometric factors right away, so let's convert them into one form or the other. So sine 2x can be converted into 2 sine of x cos of x cos of x sine of x, and let's wait a second first. So cos 2x cos squared x. Okay, so this becomes 2 sine squared x cos squared x equals to cos 2x cos squared x. Okay, now I think, yeah, okay, alright. So now what we can do, see, as you can see, this is a little bit common. So you have 2 sine squared x minus cos 2x equal to 0. So if we do cos 2x in terms of sine squared x, this becomes 2 sine squared x minus 1 minus 2 sine squared x equal to 0. So this would become 2 plus 2, 4 sine squared x minus 1 equal to 0. Okay, now we have two equations. So either cos squared x is 0 or sine squared x is 1 over 4. So either cos of x is 0, which actually just simply means x is equal to 0 because no, sorry, x is equal to pi by 2, sorry. Wait, do we need it in yeah, okay, pi by 2. Okay, so x is pi by 2, and this one, this can be converted into sine of x plus minus 1 over 2. So obviously the minus 1 over 2 will be discarded because the range that we have does not support that. So we will do sine inverse of 1 over 2, which is going to be pi by 6. So since m is clearly before pi by 2, so x coordinate of m is x is pi by 6. Okay, alright. So by using the substitution, u is equal to cos of x, find the area of the region bounded by the curve, the x-axis between x is equal to 0, pi by 4, and the line x is equal to pi by 4. So if this is pi by 6, pi by 4 would be slightly ahead of this, like halfway between 0 and pi by 2. So we basically need this particular area. Right? Okay, so from 0 to pi by 4. So 5 sine 2x cos squared x cos squared x. Right, okay. Dx from 0 to pi by 4. Okay, so we need a u cos of x. Okay, so so du over dx is minus sine of x, right? Okay, sine 2x can be broken into 2 sine x cos x, so this becomes 10 sine x cos cube x dx, 0 to pi by 4. So when you start to convert it, this is u cubed, du is minus sine x dx, right? So this would become so sine x dx would be minus du, right? So du minus 10, right? Okay, now we also need to substitute the limits also. So cos of 0 is 1 and cos of pi by 4 is under root 2 over 2, right? So 1 over root 2 or root 2 with and that. So you have minus 10 u raised to power 4 over 4 from 1 over root 2 to 1. Okay, so now that we plug in the limits, 10 over 4 is minus 5 over 2. This is a common constant. U raised to power 4, so 1 over square root 2, when you do the square, it becomes 1 over 2, and when you do raised to power 4, it becomes 1 over 4. So 1 over 4 minus 1. Okay, so this is minus 5 over 8 plus 5 over 2, because minus minus, right? So to add them, we need to multiply by 4, so 20 minus 5, 15, and this is 8. And this is the final answer. So area is equal to 15 over 8. That's the exact answer. And that's about it for this paper. I hope you enjoyed solving this question paper with me. If you like this video, give it a thumbs up, subscribe to our channel. If you'd like some one-on-one coaching, feel free to contact us through the contact number given or through the link tree. Either way, until the next video, take care. Bye bye.